Hello students, my name is Deependra and I welcome you all on the behalf of Think Institute of Design. In this 30 minutes demo video, we'll be discussing questions based on quadratic equations and we'll see how things happen and what things you should be aware of while going for this examination. So let's look at all these questions from the exam's perspective. So I'll be throwing certain questions and then we'll be discussing their solutions one after another. So I hope you all can see first question right there on the screen. What does it say? It says that there is an equation. First of all, you need to understand that they are saying that it is an equation. However, this equation is satisfied by more than two values of x. What you all need to understand is, since it is a quadratic equation, how can it have more than two roots? It should have exactly or at most two roots, which means this cannot be an equation. What you all need to understand is that if you are told that there is an equation ax square plus bx plus c is equal to 0, it cannot be an equation if it has more than two roots. Hence, I'll be calling it an identity. I hope you're getting my words very clearly. Now, what is an identity? Identities are kind of equations, but they are kind of expressions which are true for all the values of x. For example, when you talk about a plus b whole square, that we all know is always a square plus b square plus c 2ab. Now, irrespective of any value of a and b, this is always going to be true, which means LHS and RHS are always going to be same. That's my point. So if you all have seen this, what you all need to understand is here, it is not dependent on x. This question is not dependent on x, which means it should be independent of x. And if it is independent of x, LHS and RHS should be true, should be equal for all the values of x, which will happen when the LHS is 0 because RHS is 0. Now, without bothering about x, how can I keep or make LHS 0? All I need to do is make these coefficients, coefficient of x squared, coefficient of x, and this constant term 0. So when you talk about the coefficient of x square, what is it? It is lambda square minus 5 lambda plus 6. This is your first coefficient, which is coefficient of x square. That should be 0. Next is lambda square minus 3 lambda plus 2. This should also be 0. And next coefficient, or rather the constant term you are given is lambda square minus 4. All of these should be 0, which means I should put an and between them, which means all of these three conditions should be satisfied. Now, when you proceed further, what you clearly see is that these three equations should be there. Now, I hope this quadratic, when solved, I hope you all know that splitting the middle term is what I'll be using. So I'll be writing it as minus 2 lambda minus 3 lambda plus 6 is equal to 0. Here, I can write it as lambda square minus 2 lambda minus lambda plus 2 is equal to 0. And here I can write it as lambda plus 2 times lambda minus 2, or I can directly write lambda square is equal to 4. Now, here I hope you know, first factor is going to be lambda minus 2, and the second factor is going to be lambda minus 3 is equal to 0. Here the first factor is going to be lambda minus 2, and the second factor is going to be lambda minus 1 is equal to 0. When you take the square root on both these sides, it gives you lambda is equal to plus minus 2. I hope you all understand that. Now, from here, I can crack that the values of lambda are going to be 2 and 3. Here, the value of lambda is going to be 1 or 2. And here, the value of lambda is going to be plus 2 and minus 2. Now, what I need to ensure is that it should satisfy all the values. I mean, whatever value of lambda you take should give you 0 here, a 0 here, and a 0 here. What I'm thinking is that 2 is common for all these three equations, which means, please understand, if I take the value of lambda as 3, this coefficient will become 0, but this and this won't become 0. I hope you're getting my concept. So I cannot take 3. Similarly, I cannot take 1 and I cannot take minus 2. So the only value which is common among all these three equations is 2. So if you put a 2 here instead of lambda, this part becomes 0, this part becomes 0, and this part also becomes 0, which means LHS is going to be equal to RHS, which means it is going to be independent of x, which means it can have or it can be satisfied for more than values of x, for more than two values of x. Rather, it will be satisfied by any value of x because it is now behaving as an identity. So when somebody says that find the value of parameter lambda, I wouldn't say the answer will be 3 or 1 or minus 2. I will clearly say that the answer is going to be 2. That will be my final answer. Now, when you proceed further for the next question, have a look at this. Now, the next question, when you talk about the next question of the day, it is again a very simple one. First of all, you need to understand what is your next question. So here it is, again, based on the same concept, quadratic equations. When you pay attention to the details, you can easily crack what is given and what is asked. First of all, look at this data. I mean, I want you all to pay attention to this data, which is 5 plus 2 root 6 and 5 minus 2 root 6. Forget this question. Let's talk about what I have written on the screen. Can you help me in figuring out what is going to be the value of this expression? I hope without any hesitation, you all can clearly conclude that it looks like the identity a plus b times a minus b, which is a square minus b square. So square of 5 is nothing but 25, and square of 2 root 6. Square of 2 is 4, root 6 ka square is 6, 6 into 4 is 24. So 25 minus 24 is clearly 1. So I get a 1 here, which means that this and this, when multiplied, gives you 1. That concludes that these two are reciprocal of each other. I hope this part is very well understood by all of you. What I'm trying to make you all understand is that if they are the reciprocal of each other, can I not say that 5 plus 2 root 6 should be equal to 1 by 5 minus 2 root 6? Or in a more simpler language, can I not write it as 5 minus 2 root 6 whole raised to the power minus 1, whichever suits you. Now, why are we discussing all this when solving this question? Please understand, for a while, can I take 5 plus 2 root 6 whole raised to the power x square minus 3 as, let's say, k? Now, when you do so, what you do is, I hope you understand, 5 plus 2 root 6, right? This particular expression, which when simplified, I hope can be replaced by 1 by 5 minus 2 root 6, which means this entire expression could have been written as, please pay attention to this, 1 by, listen to this students, 5 minus 2 root 6 whole raised to the power x square minus 3, which is also going to be equal to k. Now, why am I writing all this, or why am I suggesting all this? My point is pretty simple, students. If I take reciprocal on both the sides, can I say here, it will be 5 minus 2 root 6 raised to the power x square minus 3. And here it will be 1 by k. I hope you all realizing that 1 raised to the power x square minus 3 will result in 1. So that does not matter to us. Now, if you pay attention to this part, I hope you are realizing 5 plus 2 root 6 whole raised to the power x square minus 3 can be replaced by k. So this entire expression I'll be replacing by k. What about this? This expression, which is 5 minus 2 root 6 whole raised to the power x square minus 3, will get replaced by 1 by k. So this is k plus 1 by k whole is equal to 10. Now, what we are now stuck with is solving this particular quadratic equation. So let's try and solve this particular quadratic equation. So when you do so, how do you solve this question, students? See, just give me a second. I'll grab it here so that it becomes more visible and clearer to you. Now, I am multiplying k to both the sides. So when you do so, what you get is, see, I'm just dragging it here. Now, when you multiply k on both the sides, you get k square. Then this becomes 10k, which is brought on the left hand side minus 10k. And here it is left with 1. So that becomes 1. So this is your quadratic equation now. Now, I think that splitting the middle term might not work here. So what I'll do is I'll solve it with the help of quadratic formula. Now, what does quadratic formula say? I hope you all are aware of it. So I'll directly write the value of k, which is going to be minus b, which is plus 10, plus minus under root over b square minus 4ac. So b square is going to be 100 minus 4ac, that is plus minus 4, right? Divided by 2a, that's 2. Now, 100 minus 4 is 96. I hope you know that. 96 is, I think, 4 times of 24, I believe. Yes. So if it is 4 times of 24, can I not say it as, 24 can be written as 6 into 4. So that can be written as 16 into 6 as well. Now, what can you conclude about square root of 96? That means square root of 16 into 6. What does it mean? Can I write it as, 4 times under root 6, which means the value of k I am receiving as 10 plus minus under root over 96, which is 4 times under root 6 whole divided by 2, which eventually gives you the value of k as, 5 plus minus 2 root 6. Now, that's the most crucial and interesting result which we have received so far. Now, what is the value of k? This. But what was our value of k? So what we assumed k as this. I hope you are realizing that we assumed k as this. So both the values can be equated. So I got two values of k. One as 5 plus 2 root 6, other is 5 minus 2 root 6. So I'm taking value of k as 5 plus 2 root 6. However, here the value of k was given as 5 plus 2 root 6 whole raised to the power x square minus 3. I hope you are understanding. base are same on both the sides, which means powers can be compared. So it gives you x square minus 3 is equal to 1, which gives you x square is equal to 4. And from here, I get the value of x as plus minus 2. So this is first result or first conclusion or first two values of x. However, we still haven't considered the other value of k, which is 5 minus 2 root 6. I hope you're realizing it. So this is the value. And what was the value of k? The value of k was this, which is 5 plus 2 root 6 whole raised to the power x square minus 3. On the left hand side, what we are given is 5 plus 2 root 6. Can I replace this value by 5 plus 2 root 6 raised to the power minus 1? Because we have already concluded that 5 plus 2 root 6 can be replaced by 5 minus 2 root 6 raised to the power minus 1 and vice versa. So again, since base are same on both these sides, can I compare the powers? So x square minus 3 is equated with minus 1, which gives you the value of x square as 2. And eventually, the value of x turns out as plus minus under root 2. So there are 4 values of x which you have received, and these are those 4 values. I hope you are pretty much confident with this solution, the approach, and what kind of questions asked from the quadratic equations, and how should you look at them. Now, if this question makes complete sense, I think it's the time that we focus on the next question for the day. Again, a very interesting question which will give you a lot of insights. So let's focus on the next question for the day. Here we are, students. Have a look at this. This uses another interesting and a different concept of the quadratic equation. Now, what happens here is, forget this question. Again, I'd like to, take you to the theory part of this question, which is going to be used in this question. I hope you know that if there is a quadratic equation, ax square, let me just zoom it a little so that it becomes more properly visible to you all. So I'm dragging it here. I hope it is properly visible to all the participants. So this is ax square plus bx plus c is equal to 0. Now that's a quadratic. I'm assuming it has two roots, alpha and beta. Now, what I know about alpha and beta is that sum of the roots, alpha plus beta, is always minus b upon a. And the product of the roots, that is alpha beta, that is always c upon a. Now, had I asked you, what can you say about the difference of the roots? Now, forget the difference of the roots. Let's say alpha minus beta whole square. Can I not say that alpha minus beta square is alpha square plus beta square minus 2 alpha beta? However, let's say I add 2 alpha beta to it and I subtract 2 alpha beta from it. Now, why have I done it? You'll realize it now. I am now looking at two different things. Which two different things? Alpha square plus beta square plus 2 alpha beta. When you club this all up, can I not write it as alpha plus beta whole square minus 2 alpha beta minus 2 alpha beta when added give you minus 4 alpha beta. And on the left hand side, you get alpha minus beta whole square. Now, why have I done all this? You'll realize it now. Please understand. See, alpha plus beta, we all have already cracked as minus b upon a. So minus b upon a when squared gives you b squared upon a. That is 4 times alpha beta, which is c upon a. So that is 4c upon a. I hope, sorry, this is going to be b square upon a square because whole minus b upon a should be squared. On the left hand side, you have alpha minus beta whole square. Now, why are we discussing all this? See, if I multiply this numerator by a and denominator by a, I get the LCM as a square. So in the denominator, I get a square, and the numerator, it is b square minus 4ac. By looking at this b square minus 4ac, I hope you all must be able to conclude that it is the discriminant. I hope you know that. Now, can I say alpha minus beta whole square turns out as discriminant upon a square? So when you take square root on both these sides, I am putting a mod over it because it can be either positive or negative. Hence, I'm putting a mod over it, which gives you under root over d divided by under root of a square, which is mod of a. I hope you know that under root of x square is not just x, it is mod x. Now, that is something which you all need to remember, and I hope most of you are clearly aware of it. I repeat, under root of x square is never x, it is mod x. You need to know the value of x. I hope it is clear with this part. Now, what we have concluded so far is that the difference of the roots is always under root d upon mod a. Now, that is something which we have concluded so far. Now, why are we discussing all this? Let's again shift our focus on this question. This was the question given to us. Now, if I look at this question, students, why are we discussing that part where I have concluded that alpha minus beta, the difference of the roots is under root d upon mod a. Now, that's a learning which you all should remember. This is something which you all should memorize and by heart because it is going to be used in a lot of questions and you should be aware of it. Now, I'm given two quadratic equations. One of the quadratic equations is x square plus ax plus b is equal to 0. And the second quadratic equation was x square plus bx plus a, right, is equal to 0. What I am told is that the difference between the corresponding roots of this equation and this equation is same. Now that's the crux of this question. Let's say the roots of this equation are x1 and x2. The roots of this equation are x3 and x4. Now, can I conclude that the difference of the roots x1 minus x2 from here is going to be discriminant of this quadratic? I hope you know that. Discriminant is given by this a square minus 4 into 1 into b, that is 4b, whole divided by coefficient of x square, which is 1, and mod of 1 is 1. So I need not write this 1 here. Similarly, difference of roots x3 minus x4 is going to be what? It is going to be under root of discriminant of this quadratic equation, which is going to be b square minus 4 1 into a, that is a, divided by modulus of coefficient of x square, which is 1. So this is going to be 1. And what we are told that these two values are same. So when these two values are same, I hope first of all you need to understand that you need not put a mod sign over here, because this is going to be, this numerator is going to be anyway non-negative. This is 1. So something positive upon positive is going to be positive. Here also something positive on positive is going to be positive. So the values are going to be positive. So I need not put a mod over it. I hope you're getting my concern. So with that, this part and this part should be equated. So when you equate both of these parts, what result do you get finally? Let's have a look at that. See, here I am getting the result as a square minus 4b, and there I'm getting the result as under root over b square minus 4a, and these two values were equal. So when you square both these sides, what do you get? You get a square minus 4b on the left hand side and b square minus 4a on the right hand side. Now, I'll take both the values, all the values on the left hand side. So I'm left with a square minus b square minus 4 times b plus 4 times a whole is equal to 0. So I'm taking this, under consideration and converting it into an identity. The identity says that a square minus b square can be written as a plus b times whole of a minus b. And here, minus 4 when taken common, or rather, I'll take plus 4 common. So when you take plus 4 common, you'll be left with a minus b whole is equal to 0. I think a minus b from here and here can be taken common. So when you take a minus b common from both these sides, from both the terms, so a minus b as a factor comes out, and then you're left with a plus b plus 4 whole is equal to 0. Now, this factor cannot be 0 because we were told that a and b cannot be equal, which means this factor is going to be 0, which means a plus b plus 4 should be 0, which helps you in understanding that a plus b should be equal to minus 4. Now, that is something which you have concluded, and that's exactly what we were asked. What is the value of a plus b? And I hope you all are realizing it is going to be minus 4. So I hope it makes complete sense that how are we solving this category of questions, and you're getting a lot of clarity that this is how you're supposed to solve this kind of questions. Now, again, another very interesting question based on the concept of wavy curve method. Now, we'll be learning another different important concept, which is very widely used and asked. It is called wavy curve method. It's not wavy, it's wavy curve method. Now, how do you solve it? Basically, it is an inequality, but inequalities cannot be just solved the way we solve equations. There are certain different methods through which you solve inequalities. So, first of all, you need to understand the inequality is given in this manner, that 2x divided by 2x square plus 5x plus 2 greater than 1 upon x plus 1. So what I do is, I bring this 1 upon x plus 1 on the left hand side. So when you bring it on the left hand side, what you do is, just give me a second, participants. You put a negative sign here, and this becomes greater than 0. I hope you know that I'm shifting it on the left hand side. Now, what I do next is, I'll simply cross multiply, take the LCM and do the rest, which means 2x gets multiplied with x plus 1, which gives you 2x square plus 2x minus, this gets subtracted, which is 2x square minus 5x minus 2 whole divided by product of these two denominators, which is 2x square plus 5x plus 2 multiplied by x plus 1. So I'll not multiply it. I'll just keep it like this, 2x square plus 5x plus 2 whole multiplied with x plus 1. And this expression we want to be positive. Now, what I do next is, please pay attention to this. This 2x square, I hope, is properly visible to all of you, gets cancelled by this 2x square. Then this 2x minus 5x leaves you with minus 3x minus 2 whole divided by, now 2 times 2, that's 4. So I need to split this middle term. So which means when I am going to write it as 2x square plus 4x plus x plus 2 times whole of x plus 1 should be greater than 0. I hope this much part is very well understood by all of you. Now, what I do next is, please pay attention to this part, students. What we are suggesting that please split this part as well. Now, can I take minus 3 common from the numerator? I hope that can be done. So when you take minus 3 common from the numerator, minus 3 times, you're left with x plus 2 by 3. I hope you're comfortable with this data. In the denominator, from here, when you take 2x common, the factor is going to be x plus 2. So one of the factors is going to be x plus 2. And since you have taken 2x common, to make this as x plus 2, I'll be taking 1 as common. So other factor is going to be 2x plus 1. And then, of course, you are left with x plus 1. And this expression should be positive. Now, one more thing I'm going to do is I'll take 2 common from here. So when you take 2 common from here, it is going to be minus 3 by 2 whole of c. Now, this whole of what? Numerator will have x plus 2 by 3. And the denominator will have x plus 2 times x plus 1 by 2 times x plus 1. And this should be positive. Now, inequalities follow a certain rule that if you multiply an inequality by a negative number on both these sides, its sign changes, which means if minus 3 by 2, I want to get rid of, so I'll multiply it by minus 2 by 3. So when you multiply minus 2 by 3 on both these sides, it gets eliminated from here. 0 into minus 2 by 3 is 0. But this sign, which happens to be a sign of greater than, will get converted into a sign of less than because I've multiplied this inequality by a negative sign on both these sides. I hope this part doesn't confuse you all at all. Now, what is the relevance or significance or importance of this particular step? Now comes wavy curve method into picture. Now, what I am going to do is I'll draw the number scale. I hope you know that number scale has minus infinity on the extreme left and positive infinity on the extreme right. Now, if I take the critical point, now how do you evaluate the critical points? You put this factor x plus 2 by 3 equal to 0. And the value of x you receive as minus 2 by 3. So I think minus 2 by 3 will be somewhere. Let's say I'll put minus 2 by 3 here. Now, I put this factor equal to 0, which is x plus 2. So x plus 2 when put equal to 0, you get the value of x as minus 2. I think minus 2 is smaller than minus 2 by 3. So I'll put it here. I hope no one is confused with that part. Then I'll put x plus 1 by 2 equal to 0. I'll get the value of x as minus 1 by 2. Now, between minus 2 by 3 and minus 1 by 2, I hope I need not tell you which one is lesser or greater. And if you ever get confused, all you need to do is forget these negative signs for a while. So 2 by 3 and 1 by 2. I hope 1 by 2 is approximately 50%. This is 66%. So 66 numerically is great, but when this negative sign is considered, it should become smaller. So I think minus 2 by 3 will come on the left-hand side and minus 1 by 2 will lie somewhere here. Now, I am going to get another critical point, the value of x as minus 1. Well, this is going to be, of course, here. So I put minus 1 here. I hope this part is very well understood by all of you. I hope no one is confused with that. Now, what I am going to do next is I'll put a positive sign here. Now, that's the wavy curve method. A negative sign here, another positive sign here, another negative sign here, and another positive sign here. That is wavy curve method. Now, what were we asked? We were asked all the negative values. So all the negative values are happening between minus 2 by 3 and minus 1 by 2 and minus 2 and 1. So I would say that x belongs to all the values between minus 2 and minus 1, open bracket, because I cannot put them equal to 0. This should be just less than 0. And of course, along with this, some more values which are lying between minus 2 by 3 and minus 1 by 2. So these two are also should be included. So I hope you're getting the idea that how are you solving this category of questions and how should you approach questions based on wavy curve method. I hope you're getting a complete clarity, a crystal clear clarity on this category of questions. With that, let me take you towards another category of questions, which gives you a different insight on the concept quadratic equation. So let's pay attention to another concept for the day. I'm bringing it in front of you. I hope you all are able to understand the lecture comfortably. You're finding it understandable that how are things happening and how are you supposed to solve all these category of questions. Now look at this question, another very interesting question. We asked find all the values of p so that 6 lies between the roots of this quadratic equation. First of all, understand that if you are given a quadratic ax square plus bx plus c is equal to 0, if the coefficient of x square, which is a, is positive, then we know that it is going to be an upward facing parabola. The graph of this quadratic expression is going to be an upward facing parabola. So if I look at this particular equation, I hope you all must have noticed that it clearly gives you the quadratic. This quadratic gives you a clear idea that here the coefficient of x square is 1. I hope you all know that. So if coefficient of x square is 1, which means it will, I hope you can see this 1 over here, the 1 times x square. So this means it is going to be an upward facing parabola. So the graph of this quadratic expression is going to be an upward facing parabola. Now, what they want you all to do is that, of course, there will be an x-axis, there will be a y-axis. They want two distinct roots of this equation. Why am I saying two distinct roots? Because 6 should lie between the roots of this equation. So there should be two real roots and 6 should lie between them. For example, if alpha is here, beta should be here and 6 should be somewhere here. I hope you're getting this idea. Now, how are we going to solve this question? Please understand two things I have mentioned very clearly. First, that the roots, let's say the roots are alpha, they should be real and distinct. That's the first condition. And when somebody says that the roots should be real and distinct, the discriminant of this quadratic should be positive. It should not even be 0, it should be positive. The second condition is going to be that when you figure out the value of this quadratic expression, let's say the quadratic expression is f of x, which is x squared plus 2 times whole of p minus 3 times x plus 9. Now this f of x at c, at 6, I hope you can see, should be negative. Why am I saying that f of 6 should be negative? Because before alpha, it is positive. After beta, it is positive. But between alpha and beta, it is negative. It is below the x-axis. So at 6, the value of this quadratic expression should be negative, which means the next conclusion will be f of 6 should be negative. So these are the two conditions I'll be imposing. Now, if I begin with the first condition, the discriminant should be positive. What is going to be the discriminant? B square. So it is going to be 2 times p minus 3 whole square minus 4a, that is 1, into c, that is 9. I hope you are comfortable. This is 2 times p minus 3 whole square. This should be positive. When you simplify this, 2 square is 4. So this is 4 times p square plus 9 minus 6p minus 4 times 9. That should be positive. I take 4 common from both these sides and eliminate it because 4 is a positive quantity and need not bother about the signature of the equation. So here on this part, I'm left with p square. See, this 9 and this 9 will get cancelled. I hope you are paying attention to this because a 4 was there on both these sides. So I'll be left with minus 6p greater than 0. If I take p common, I'll be left with p minus 6 greater than 0. Again, I'll be using this wavy curve method. And what does wavy curve say? One of the critical point is going to be 0. The other critical point is going to be 6. I'll put plus, minus, plus here. I wanted it to be positive. And when you want it to be positive, you say that p is going to be either greater than 6 or less than 0. So first of all, I could get the value of p, which is not the final answer. But from here, I could at least conclude that p should lie between either minus infinity to 0 or 6 to infinity. This is not the complete answer. We have one more condition left, which we need to verify, check, or validate. Now, f of 6 should be negative. What is f of 6? F of x. So I'll replace x by 6 over here. So what is going to be the value of f of 6, students? That is going to be 6 squared. It is 36. That is going to be 2 times p minus 3 times x, which is 6 plus 9. And this should be negative. I hope you're getting it very clearly. Now, when you simplify or solve this part, what do you get finally, students? See, this is going to be 3 into 6. That I think is 18. 18 into 2 is 36. 36 gets cancelled by this 36. I hope you're getting it. So what I'm finally left with is 2p plus 9 should be negative. I repeat my statement. This 36 gets cancelled by 6 into 3. I'm really sorry. I hope I haven't. Yes, I have made a mistake. I'm just correcting it. I'm just writing it completely so that you don't get confused. See, I had a 36 here. Then 6 into 2 is 12. 12 into p is 12p. So I wrote it as 2p mistakenly. Now this is minus 36 plus 9 should be negative. I hope you're getting it now. I hope there's no confusion so far on this. Now, what I'm suggesting you all to do is, see, here, this 36 gets cancelled by this 36. So you are getting 12p less than 9. If I simplify or cancel both the sides by 3, I get, or rather I can write p as, I have made a mistake. It should have been negative because this was positive. So p should be less than minus 9 by 12. What is minus 9 by 12, students? Minus 9 by 12 is 3 times, so minus 9. And 4 times of 3 is 12. So this is minus 3 by 4. So one more condition we are going to impose is, see, minus 3 by 4 will lie somewhere here. And it says that it should be less than that, which means it should be less than minus 3 by 4. Now, if I take intersection of both, because this and this both should be satisfied. So I'll conclude that it should be less than minus 3 by 4. So it says one of the solutions is this. The other solution is that it should be less than minus 3 by 4. So the more specific, more prominent, more narrowed solution or more precise solution will not be this, but this, because I'm supposed to take the intersection, the common values of both. So the common values in both are these. So the final answer will be that P should lie between minus infinity to minus 3 by 4. So if you take any value which is less than minus 3 by 4, you will always get the roots in such a manner that 6 will always lie between the roots. I hope this part makes complete sense and you are able to understand how should you solve this category of questions. With that, I believe you have gotten a lot of clarity on quadratic equations and we are calling it a day. Thank you so much, everyone.